Okay, so writing composite functions can be challenging. The domain also gets to be challenging once you do the composition. So I thought I'd do a couple of these to help you out. So this is from page 66. This is 60 and this is 61, and these are the kind of question you're asking me about. So question number 21 is here, and they're asking us to find f of g of x. We're going to drop g into the f function. So that's what I did here. You see how f of x is 1 over x minus 6? So 1 over, and then it's the minus 6, and then the x, that x I replaced to that whole thing. Now, maybe if you watch one of my other videos, I've done this on that other video. But if this is the f function, f says take 1 over something and subtract 6. So what we're doing is we're dropping something into that x. And if we're doing composite functions, I'm dropping in that whole, to find f of g of x, I'm dropping that piece right into that space. And then what comes out is this. Now, then they said simplify your answers. Well, since this is looking for that, well, let's do it. So I just see a 1 in front of the parentheses, so there's nothing there. I can just drop the parentheses. I don't have to worry about that. So that's going to become 1 over 7 over x plus 6 minus 6. Well, combining like terms now, the 6's cancel out. That leaves me 1 over 7 over x. And remember, anytime you see a 1 over, that means take the reciprocal. So I'm going to flip the 7 over x to get x over 7. It would also be appropriate to write that as 1/7 x if you wanted to do it that way. So that's how that simplifies that, and I hope that helps. Um, then so it's just, you can try that on yours. This part's easy, and on an exam, that's fine for me. You could leave it like that, unless my open math or it's a multiple choice where you got to manipulate it a little bit. Okay. Now, what about how about the substituting them in the other way? We're dropping uh, f of x into g of x. So g of x says 7, let's see, what does it say up here? It says 7 over something plus 6. So I'm going to drop in that whole g of x function right in there on the denominator. That's what I did here. Okay, let me clean up this a little bit for you. Okay, so because I've got 7, see, I can't, unfortunately, in this part, on this composition, I can't just subtract the 6 and the 6 yet, since this is tied up down in the denominator. So this, I've got to concentrate on that compound fraction, and remember, all a fraction bar means divide, so let's think about it that way. This is going to be 7 divided by 1 over x minus 6, and then plus 6 here from before. Well, when I'm dividing fractions, I have to take the reciprocal, right, and multiply, right? So I'm going to change that to x minus 6 plus 6, distribute the 7 through 7x minus 42 plus 6, and then, of course, now we can combine those like terms. The negative 42 plus 6 is, what is that? Negative 36. So that cleans up to 7x minus 36. Okay, a couple of nice linear functions. And of course, that's deceiving if we start thinking about domain, because uh, we're not losing those original domain limitations. That answers your question. Maybe I'll do this next little piece, and you can skip over this next little piece if you're not ready for it. Let's talk about the domain limitations here, because that's really where this gets hard. I think for me it gets hard, so I always have to think about it a little bit. Okay. So for the f of g of x, the limitation is, well, there's a couple of things going on here. I know that original domain limitation for f of x is, hey, x can't be equal, so I got the 1 over x minus 6. Well, I can't divide by 0, so when x equals 6, that's a problem. That's where there's a division by 0. So originally f had a domain limitation of x can't be equal to 6. And now the other domain limitation is, g of x, if I look at g of x here, that g of x can't be equal to 0, right? So then I forget how that cleaned up. The other thing we got to deal with is this whole mess can't be equal to 0. How is that the same? Sometimes it's exactly the same. So when does, well, let's solve that equation. 7x plus 6 minus 6 can't be 0. So 7 over x, well, negative 6 plus 6 is 0. So then I get this one. 7 divided by x can't is equal to 0. Well, that's never going to happen because the only way that can happen is if the numerator 0 divided by a number gives me 0, right? And that's set, and the numerator is always 7. So we don't even have to worry about that because that'll never happen. So the only domain limitation we have to worry about, I guess, is um, x can't be equal to 0. Let's check it out. Let's graph it. Check it out. So I did graph. This is actually, I'm very glad this happened because graphing is a great technique. Sometimes it lies, and in this case, Desmos is lying to us. See, I said here's the two separate functions, and then I had it graph the composite, and then when I clicked on the, see, I would just said x can't be equal to 0, but when I plug it in there, it's not giving me an undefined. But that can't possibly be right, and here's why. If I were to treat these separately, let's go look back up here at number 21 again. If I asked you to find f of g of 0, and I wasn't looking at that composite function, I was just looking at the original functions, g of 0 is equal to 7 over 0 plus 6. I can't divide by 0. That doesn't happen. So 0 is not in the domain. F of g of 0 doesn't have an output because I can't get a g of 0. And even though the equation cleans up, that original domain limitation cannot disappear. It's always there. So I'm glad this happened. We got to be smarter than what the computer's telling us. So that's great. So, but anyways, I answered your question about how to write the composite function, the simplified composite function. Let me go on to do another one. So this is number 23, and again, they're asking us to find f of g of x and then clean it up. So I dropped that into x, and now to clean it up, I got to follow order of operations, and I'm going to square root, so that becomes x plus 2 plus 1. Well, that's equal to 3. X plus 3. So that's what that form is cleaned up. That's what they're looking for in the back of the book. Now, to go the other way around, to where I'm going to drop this in under the square root, see, that's what I did there, and to clean it up, I see 1 and 2 are like terms. So x squared plus 3 square root, and that's that cleaned up. Now, so that's that question. I hope this is all understands, gives you a handle on what's happening with this. The fractions can be difficult. Do I want to take the time to talk about domains here? Sure, and then maybe I'll do one more. So for f of g of x, we're dropping this into here. So if you think about x for this one, x has to be greater than or equal to -2, right? Because I can't take the square root of a negative number, but I can take the square root of 0. And this doesn't have any domain limitations. So this initial domain limitation on f of x is what stays. So even though what did that work out to be? X plus 3. X plus 3 is that composite function, but x, the domain, would have to be x greater than or equal to -2. Be interested to graph it. If you want to do that, post it in the discussion forum. See if that works for this case. That'd be great. I'm not going to take time to do it right now. And then for the f of g of x, because f of x has no domain limitations. That's a nice polynomial, so we aren't going to worry about that. But and then here, x squared plus 3, that's still underneath the square root. Is there any place where that has a domain limitation? Well, That only happens if x equals negative, if x squared equals -3, then that would be division by 0. Is that ever going to be a negative number? Well, think about this. If I have x squared equals -3, if I take the square root of both sides, that's going to be x equals, I can't take the square root of a negative number without going to I. So there's no domain limitations on this composite function. And so if I graphed it, I would see something like that. So there's a situation where it's kind of cool. We know x can't be. The other thing to ask us is x plus 2 has to be greater than 0. We said, right? So so x is greater than -2. Is there any place that x squared plus 3 will be greater than -2? Well, x squared, it has to be greater than -5. Well, again, we're running into that square root of a negative number. So yeah, there's no domain limitations on that composite function. Check out the graph and share it with us if you want. Okay, I guess that's a long enough video. Hopefully this helps you. Oh, maybe I'll go back and do the one you posted in the discussion forum. So this is actually just like that number 21, right? Because it's the same kind of setting. So what will f of g of x be? You can stop the video and try it, and now that you saw that other one, and then come on back or just keep listening. So I'm gonna drop. Let's see, what am I gonna drop? I'm gonna drop 1 over 3x plus 7 minus 7. Okay, replace that x. Replace this x with that whole thing. So I guess to clean that up, what are we going to get? We're going to get 1 over 3 over x, because the plus 7 minus 7 cancels out. And then we take the reciprocal, so x over 3 is what Mass is looking for. And then if we do it the other way, g of f of x So we're going to say 3 over plus 7. So we're going to drop in the 1 over x minus 7. And that requires us, like the other one, right, where we had to, what am I going to do here? The whole thing up. There it is. So I'm going to take the reciprocal. So that becomes 3 times x minus 7 over 1 plus 7, distribute that through 3x minus 21 plus 7. So I'm seeing 3x minus 14 there. Okay, so hopefully that helps you out. Yeah, it's on minus 14, not plus 4, right? Okay, hope that helps.